Hi class, this short webinar is meant to supplement my recordings for the endocrine system, and specifically looking at the adrenal gland. This is going to have the pictures that are actually in your notes. The previous recordings had slightly different pictures, but I just want to make sure you can fill in your notes. So what we're going to do with this recording is look at the cortisol, which is secreted by the zona fasciculata of the adrenal cortex. And I want to look at the effects as well as targets. So one of the targets are certain immune cells, mast cells, neutrophils, and macrophage. What it does is it decreases histamine release by mast cells, and that would act as an anti-inflammatory reagent or agent. Because the histamine released by mast cells is really important in stimulating inflammation. It also is involved in inhibiting phagocytosis, which macrophage and neutrophils are phagocytes, so it inhibits the phagocytes and inhibits other things, but I'm just going to leave it at that. So big thing that glucocorticoids do, like cortisol, is it is an anti-inflammatory agent. And all these three cells here are important in inflammation. Now, other targets include liver, which is right there, skeletal muscle, which is there, and adipose tissue, which is there. So let's just kind of fill in kind of what it does. So one of the things it does is it stimulates the breakdown of muscle. So stimulates muscle degradation. I'm writing muscle degradation, but you should indicate stimulates muscle degradation. And what you get out of it is you get some amino acids. So this is representing an amino acid. The amino acids can be used by the liver to make glucose. So it stimulates something called gluconeogenesis. Another thing is it stimulates glycogenesis. So I can take that glucose but then store it away in times of acute stress, and which is indicated here by this plus E. So when you're in fight or flight mode, epinephrine is released. That epinephrine stimulates the breakdown of glycogen, but cortisol doesn't. Cortisol stimulates gluconeogenesis and glycogenesis by the liver. Now in adipose tissue, it stimulates the breakdown of muscle or lipolysis. Again, I'm not writing stimulates. You should be able to write down stimulates. So it stimulates lipolysis, and what you get from the breakdown of fat is here's a glycerol backbone, which can be used by the liver to make glucose. These are fatty acids. Okay, so we have fatty acids. Fatty acids could be used for energy. And actually that's going to be used for energy by that liver to be able to do things like gluconeogenesis and glycogenesis, because they are very anabolically costly processes. Now over here on the left, it kind of leads to showing you here, this is supposed to represent cortisol. And it's coming from the zona fasciculata of the adrenal cortex. And what these are, they're supposed to indicate, so it's like things like just various types of stress. It could be in large numbers of stress that triggers the hypothalamus to release what this is supposed to be is CRH, which then targets the anterior pituitary, which stimulates the release of ACTH. And this squares is representing ACTH. That targets the adrenal cortex and stimulates the release of cortisol. And then you see kind of some of the effects there. So that's there to help you fill in your picture that's in your notes.